Well, here's a sneak peek of a few things coming up that I need to fix or set up better, whatever. I got to mount this chuck onto here, and I don't know, I got to figure out how I'm going to do that to make it quick and easy to mount every time. Quite a few new tools here and more coming. Here's my new bandsaw. Making a lot of racket over here, but it seems like it's working okay. I'm going to make some T-nuts for that rotary table. Here it is cut. I haven't hooked the coolant up yet. I just squared it up. This is the first cut, or second cut, I guess. I'll cut this off the end. Anyway, I gotta work on this crazy diesel though, get this done, but I'm probably gonna take it to this little mill and build some T-nuts. Was my first thought. I need some T-nuts for this rotary table. They're a different size than what I have to mount this. This is an 8-inch rotary table, 8-inch chuck. Has these bolts that go in here, which naturally are metric 10 by 1.5. But I don't know if it's going to be. Okay, the saw finally finished. Quit making racket over, so I think the width of these bolt holes is 3 3/4. I'm sure it's in a metric value. I don't remember what that is, but not real important. And I think the T-nuts that I have, let me show you real fast. These fit my little mill. These are 7/16, or I don't remember what they are. They could be called 12 millimeter. They do fit this. But these are 3/8/16 holes, and this is a 10 by 150, and they won't screw in. Also, these, see where this bottoms out in the slot right here? When that bottoms out right there on that radius, it's wider than 3 3/4. I don't know, but I think if I take and build some new ones, and right here put a radius on the end of this to match that radius where it'll slide up in there further. I'm kind of thinking I can get that bolted down, but that's not the end of the game, because every time you put that chuck on there, you would have to, I guess, use a dial indicator and get that turning, which is 90-to-1 gear ratio. So imagine how long that would take to turn that, and you'd have to bump this around on these T-slots until you got this running true, or wherever you test it, check it, probably put something in here, and you'd have to bump that around, which is silly. So I may have to build a faceplate to go on here, if you can see how this is made, and register it to something around here, which I may register to this. I just set this MT3 dead center in here. That's what this is. And depending on how true this is right here, I may make something that registers to that, but that's going to be awful hard to, it may not work. I'm not sure. I got to find something. Mr. Pete done that one time. I saw he had a kind of a cool way that he, on a 3-jaw, I wanted a 4-jaw just because I'm crazy and I wanted it to be where I could dial it in perfect, and a 3-jaw is not always perfect. I'll probably also get a 3-jaw to put on here just for something quick, and maybe thinking about building a plate like Mr. Pragmatic Lee has done, where you could bolt things on here quick. something small that you need a rotary table to do even for this, you know. I wanted to make a radius on this, but I'll probably just take that on a grinder or something, and I'll make one of these round on the end to fit up in that radius. I don't know, Scott, that might be a good thing to make a video on maybe this weekend. That's why I was just shooting a little bit of this stuff I was doing here at noon. I got to get back to work in a minute, and it is a mess. It's been as low as 3 degrees around here lately. Today is finally warming up. It's about 60 degrees. Well, there's the thermometer. It's been literally 40 degrees out here in the shop, and real hard to warm it up when it's 3 to 15 degrees outside. I don't remember when it's ever been that cold in this part of Texas in many, many years. It's been so long I don't even remember it being that cold. You know, we usually get 25 degree days for a little bit, and then it's gone and back to 50 or 60 degrees in the winter. So it's kind of like Adam Booth down there in Pensacola. You know, he's been seeing some 20-something degree days down there. This is a weird winter time. I guess it has to do with global warming is causing all this cold weather. I don't know, but I've got a lot of projects to do, and I just wanted to check in. I hadn't been on for a couple months or so, and you know, I've kind of been sick with the head cold and different things, and I'm just gonna try to do that little project quick. And then I've got a new mill coming. I think I told Scott that is a Precision Matthews 950, if you want to look that up. I think it's a little better quality probably than what the Grizzly was that I was going to buy. It's a full-size 9x50 table. So I'm excited and waiting on that to come in. This is a phase 2 rotary table. There's the part number if anybody is interested. It seems like the import phase 2 stuff, from what I've studied a little bit about, is a slightly better stuff than your cheapest import stuff that's for sale. Probably made by the same people, but it's hopefully a little bit better quality. I don't know. It's all I can afford right now. You know, a good rotary table like this is well over $1,000. And I think I got this one, not counting the chuck, which I also found cheap. I don't remember. It was somewhere around 300 bucks, I think, for this. This is a vertical and a horizontal. And you can get dividing plates to go in here too, so you can do quite a bit of precision dividing, which I haven't got any experience doing. I'd like to learn a lot about, maybe cutting gears or doing something simple like that, or splines or something. We'll see. Anyway, I'll get back with you on the rest of this project, and y'all take care out there. All right, Hattie, I'm working on this, as I've already made plenty of bits of footage here and there. I don't know where I'm at with this, but this video might be a few different parts because I have so many different little clips of things, but I'm not sure. Maybe we'll call this prepping for the new mill, because I think if any follows me on Facebook and stuff, you might see that I'm really scattered as usual, but I'm trying to at some point get to where I'm not taking in much mechanic work so I can spend more time with this. As you can see, I've got a few tools that I didn't used to have. I'm getting prepared for a full-size Bridgeport clone mill that I'll go ahead and tell you is Precision Matthews. I decided, I did probably tell you in the past, I was thinking about going with the Grizzly 0796, but it's a Chinese built a mill that seems to be pretty good, and there's one guy on YouTube that I know that has showed one that seemed to be happy with it, but then he just doesn't make any more videos. I forgot what his name is. You could find him if you looked up a Geo 796, but he did a real good review of that, showed all the features, but then he didn't ever make any more videos. It's been, I think, a year or two ago now, but now I'm going to I'll show you just right quick, I'm not going to spend much time here messing around. I don't know how well you see this. Let me get you in here just a little bit. I'll show you the mill that I'm, whoa, sorry about that. Here's what the mill looks like. I've talked to Matt at Precision Matthews about this, and I feel a little more comfortable with this mill than I did the Grizzly, and the money is about the same on it. And this one actually is a 9x50 table, variable speed head. See if we can get some pictures of this up a little closer. It's called a PM 950V variable. You can get this in single or three-phase. And of course I'm trying to stay away from three-phase as long as I can here, so I don't have to run some kind of noisy phase converter or nothing. So that's what this one is. It's on the water. He showed me the ship that it's coming on, and it left Japan a little over a week ago. I mean, that part of it came from Hong Kong ship, big cargo ship, and it's on that shipment, and it should be here by the end of February from what Matt thinks about that. And it comes with DRO, and it has 3-axis DRO, which is a little better than the Grizzly. It had a 2-axis. This has a Z-axis and your X and Y DRO, and it has the feed. If you can see the feed right here on the X-axis, which the other one had that as well. You can get the feeds on the Y and the Z, and I've seen mixed reports about some people say that gets in your way if it's on the Y, and I don't know yet on that. But the Z is pretty helpful for running your table up and down without a big hassle. So we'll see on all that, but I'm trying to prepare. I'll get this out of the way. I'm just showing you which mill is coming. Probably a month from now. Got a lot of preparation. If you'll notice, I've got this new Kurt vise. I don't want to mess around. When I get a full-size mill, I want big boy tools to play with. Let me back up, and I'll show you. I don't know what order we're in on this, but what I'm working on is putting this 8-inch chuck on this 8-inch rotary table that I got. And that, normally most people put a 6-inch chuck on an 8-inch, and they have room around the edge to bolt it down and try to get that centered up. Me being hard-headed like I am, I wanted to put the biggest chuck, and I wanted to go ahead and put a 4-jaw because you have a lot more flexibility or fine-tuning you can do with a 4-jaw, unless you had a just true 3-jaw, which then you couldn't put square material in probably, and you could put square or round in a 4-jaw. I would still like to get a small 3-jaw, maybe even a 5-inch or something to put on here. And you can turn this up on its side. I probably already showed you this in some videos. I'm not going to dwell on this, but you can turn this up either way and put a tailstock in here. But this little puny mill over here that I'm using, it's not a mini mill, it's just a small mill, tabletop mill. So let me put a little light on the subject and see if we can get you in here to see this. And this is a sloppy video, I'm sure, but I'm just trying to get something out here. We may run this in 2 or 3 parts if you want to limit the length of time. And oh, sorry about all the beating around here, but let's see. I know that light's in your eyes, so let me see if I can get you up here with this. If not, we'll do something different here. I know that light is probably crazy on you, but I got to get in here and do some work. If this don't look good, we'll cut it out. So I got the new, I cut this on the bandsaw. I finally got a bandsaw. I want to true this up, and I'm just going to make some T-nuts like these that will eventually have a 10 by 1.5 thread in it, and it has a radius on it right here to fit up in the slots on that rotary table. So let's just see how this works. I haven't even used this mill in so long that you know, I just haven't had time to mess around here much. I'm gonna see how this works out. I don't know if I'm centered. I'm using this 2-flute right here, and I'm not even gonna lock any of this down right now because I want to see how this works out. So let's just rub a little oil on this. This is some steel my dad had given me. I don't know what it is. It was a piece of 3/4 by 5 that he had gotten from, bought as scrap from an old place he used to work at. So let's turn this sucker on and see what happens here. Let's see. I have to turn the, I need to know what speed to run exactly. Let's run this, let's try it at around 500 or so RPMs. This is not a bad little mill, but it's just not big enough for steel. And it does have a DRO on the down on the quill here, so I can lock this and get them down there just about touching, so you can fine feed that. I'm touching it right there. I'm gonna zero that. Let's just I'm just barely touching it on the edge, so let's go ahead and let's come in about 15 thousandths and see what happens here. And I won't bore you with all this. I just want to show you what I'm doing. Still not really touching here, so let's go ahead and feed it on down to about 30. Maybe I'm not really touching it very good. Oh yeah, on that cut I made on the bandsaw, I measured both ends of this, and I kind of used a method Brian Block was showing about how to square up your saw, which is really nothing unusual. It's pretty much, this mill is a little too far up here. I'm hitting, this little mill can be moved around a little bit. It only weighs about 200 pounds, so. Alrighty, let's just keep feeding down and get this cleaned up. You can see how it may have a little chatter to it because this is a light duty mill. I usually don't do that with aluminum, but with steel, it's not really heavy duty enough for this. Take it easy, it will work. And this is not a high precision job because all we're making is T-nuts. They don't have to be super accurate. All they're doing is holding down the chuck. You know, you actually probably grind some nuts and slide in there and do the same thing, but that's what I'm doing here. So you can see this operation. I don't want to get the light in your eyes. I don't know how well this is doing. Right this way. I didn't quite clean the back up, so let's make another pass. But we did pretty much clean up all the way just fine, so see, I may need to make because this is so unrigid, if you will, it's not completely smooth. Well, it is too. It feels pretty smooth. It doesn't look smooth because it made 2 passes here. I think I'll run this a little faster and make a spring pass here. I might go 1,000, just a half thousandth or something, just to make a cleanup pass here. And this is kind of climb milling, which gives a little better finish on the, you gotta be careful when Okay, I got that milled down. Here's what I did. That piece of stock I had cut off with the bandsaw, I just squared it up real good at this point. I've got it real true on all four sides, clean. Just to catch you up so you can follow along with what I'm doing here. It may seem like a waste of time to some people, and it probably is, but I'm trying to figure out how I'm going to get that chuck on there. And the first thing I'm going to have is some T-nuts. Because I know I've showed you this over and over, but I'm trying to get it in my head what I'm doing. If you'll remember, these T-nuts, I don't know how well you see, but this has a radius right in here. I don't see my scale, but anyway, just to let you know, these won't go close enough together to get these bolts that bolt this chuck down. They need to be about right there. It's 3 3/4 spacing. It's 95 millimeters, I think, is what it is. If you want to go that route, that's what it really is. But it measures 3 inches 740 thousandths. Is what the conversion is. I don't work in millimeters because my tools don't read in millimeters, and I don't care to. None of my dials are in millimeters. That's the only reason. I don't care what it's in. I'm not going to sit here and fight and debate about, millimeters are better than inches and thousandths. I don't care. I'm not even going to debate that. I don't care which one you use. My tools read in inches, thousandths of inches. I talk in thousandths or tenths of thousandths or hundred thousandths or whatever we're working with. That's how I work. I'm not going to worry about it. I know that's in millimeters. I've got it came with some paperwork with the dimensions, and that tells me that it's 95, and I've already measured these. The spacing on these bolts on this chuck measures 95 millimeters. So if you want to call it 95 millimeters, go ahead, but I'm going to call it 3 3/4 inches. The bottom line is, I need some T-nuts because these that I had to put in a little mill over here, they won't go in close enough. So I'm going to have to grind a radius on the end of this. I could probably set this up on that little mill, but it would be crowding it, and cut them radiuses with a mill. But what's the point? All I got to do is get up here on the grinder and just grind me a radius until that'll fit up in there as far as it will, at least on this top section. I could leave this T because that slot goes underneath there a little way. So anyway, so these are they're a little bit narrow. I'd rather they fit a little better. See, they're pretty sloppy in the hole. I've got plenty of material. This is 3/4. I've already measured this. This slot is measures 830 thousandths wide. So, you know, I don't want them in there real tight. We'll just make them whatever width. Let's see what we got here left over. We could make them whatever this is 3. We can make them 3/4 or thereabout. It don't matter as long as we got some slack in there. So if that's about 830, I'd rather it be 800 thousandths max. Give us about 30 thousandths of room in there. So I may do it this direction. This actual, after I clean this up, I've got this down. This started out as 3/4 material, but it's, after cleaning it up, it's about 732 thousandths. And that's pretty true. It's 730 on that end, and same thing, 730. So it's good and square now. Not that it really has to be. That's 841 thousandths, about the same right there, 841. So it's a little wide to go in there, which is fine. So what I could do is mill that down to about 800 thousandths, just take some off of that one end, that one side there in the back of the mill. That'll give me my width in that slot, and then all I got to do is cut the top, the part that goes in here. I can't see that, maybe you can, but thinking this is about 430 thousandths or so. That measures 475 in there. I imagine they made that for 12 millimeter with some clearance. Somewhere around 470 in there, so I'd like to have maybe 20 thousandths clearance in there or something. So make this about 450 wide. See what this one measures. See, this one's 435 and it's got quite a bit of room. It don't really hurt nothing, but I'd rather it was just a little tighter than that. So it's about 425. I think I'll make that about 450. I don't remember what I already said it was. Yeah, that's somewhere around 470. I'll make that about 450, and then the height of it, it looks like it needs to be a little taller than these are too. So I don't know what time that pulls up. It ain't bad. I might make it another 10 thousandths taller than this is. So somebody's coming over the fence over there. I don't know who it is, but somebody working on the fence maybe. My dog's going crazy. You can hear him out there barking. Crazy dog. I don't know who's over there. Anyway, these are ½ inch thick, 500 thousandths tall. So we'll worry about the height of that after we get all this, but I just need to get that T. There's a lot of room in there too to make that. I don't know what the first step to be. I guess the first thing I'll do is make all these measurements to what I just said we need to do, the width and the height. Then I can mill that step anywhere I want to on that, right? So I would say make them about that same, so about 500 tall and about 3/4 wide. But we got a lot of milling to do, and I'm not going to bore you with all that. I got a lot of other work to do in here, and I may not work on this right now. I don't know. We'll see. Plus, we got the AFC and the NFC championship football games on today. Then I'm going to watch some of that. I think Jacksonville is playing the Patriots first, and then later Minnesota and Philadelphia is playing. I'm not a Patriots fan because they're a bunch of cheaters, so I think the Patriots are going to end up winning, and Minnesota's going to end up winning, and so Minnesota and the Patriots will probably be in the Super Bowl, and I sure hope Minnesota beats them sorry cheaters, but everybody's got, I don't care about either one of the teams, to be honest. Dallas Cowboys are who we got, and they're not any good for nothing, so I was pulling for New Orleans and Atlanta for a while. They both failed. Well, Philadelphia is a rival of ours because it's an NFC East team, and a lot of people around here don't like Philadelphia. Well, I really don't care anyway. It's getting so aggravating watching some of that anyway, the way the NFL players are pretty disrespectful anyway, so we won't worry about that. I'll just update you on what I'm doing here. You can follow along. Try not to make too long of videos here because I end up sitting here yakking like I'm doing now. But I'll get back with you when we have some more. Hey, I want you to watch something here. Remember I told you I'm getting a full-size mill, and Scott, you remember why I told you when you get that little lathe that Keith Rooker brought to you, how bad that makes you just want a real machine. This is an example here of why. I'll show you how you may not pick it up. It may shake the whole camera. This is a piece of steel that, or I just want to show you how much difference when we get the big mill here on how this one will do. And this is not a real small mill compared to some out there. There's a lot of smaller mills than this, but this is how crappy this thing will jump around cutting steel compared to what a real mill is. I'll just follow along with this cut here. It's about a 15,000 depth. The cut is all it is. So here we go. See how much chatter? And I'm not feeding very fast. I can slow it down and get a little better deal, but I need to rough this out. I need to take about 60 thousandths off this. This is just 15, and I'm having, this is a 3/4 2-flute end mill. This measures about 800 thousandths wide or something like that. So I'm having to make 2 passes. Basically, it's 8 passes to get my 60 thousandths. Look how bad that chatter is. It's probably shaking the whole camera. That is aggravating when you're using a little machine and it just makes you want a bigger machine. That's all I'm saying. It will get the job done if you want to mess with it. But I'd like to just have better equipment. That's why I'm trying to get a better one. Let me I'm gonna tag along with me a little longer here. That's really all I wanted to show you. But unlock the quill. Let's dial another 15 thousandths on here. Be up to 45 thousandths now on this. I need to basically make 4 more passes here. I got to do half at a time for the width. Okay, here we go. I could rub a little more oil on there. Just makes a lot of smoke. There we go. Chatter, chatter. Not a very fast feed either. I'm running about 600 RPM. Probably would be worse. I think if I was real slow, I think it'd be worse. It might not, but it's just that the machine is so lightweight, it just can't take that steel like it. Now, aluminum is pretty smooth on brass. But I need these to be able to steel. Show you the difference, and we'll show you when I get my big mill in a month or 2 here. We'll make some cuts and you'll see. You won't see this kind of chatter out of the regular size machine. It's vibrating the whole machine this way. I'm going to have to push it back. This thing's pretty heavy. I mean, I told you it weighs about 200 pounds, so remember exactly what it says right here. 202 pounds. 92 kilograms. Alright, let's get this cut. Chatter, chatter. These are expensive mills too. I think I got about 1,500 in this mill, so really can't sell this one. I'll have to keep it for little stuff. I'll go ahead and make a little spring pass on this center section. And I'll dial in the last. That shows I'm at 50 thousandths now. I was going to go about 60, 65. So make our final. I don't know why I'm turning that loose. Probably just messed everything up. Now let's dial down to about 65. Lock the quill back. Trying to eliminate as much chatter. I don't really like locking all this usually, but on aluminum I don't usually even mess with locking it. I'm not doing real precision type work. There ain't nothing real precision about this. Boy, that thing was chattering like crazy. show you. I'll get back with you. Well, had some visitors here, but I did get this machine to where it fits. This big piece here fits in here fine. I'll have to still cut it up and put some holes. See where I need to cut a radius in that so it'll go up in there further on that. See there? I'll have to grind a radius on that, cut these in 4 pieces. I may put a couple holes in here, that way if I ever need it for some other purpose, I'll have it. It's a little looser than I wanted it to be, but it doesn't really matter. It fits in there real good, and it's not above the, it's below the level of this. That's good. And it can't pull any higher, even, there ain't much slack in that. It ain't enough for it to ever pull up too high, so there's our MT3 hole. And anyway, got that much done on it. Anyway, y'all take care. I better go in here and visit with my dad. He's come over to visit. Alright, we got down to the tapping the hole with these junky snap-on taps. So they're not really, it's a 10 by 1.5, so I doubt it will cut very good, but we'll try it. I could have put that deal in there, but I didn't think about it. I guess it's not too late. Let me see if I can get it here. Didn't think about it. This ain't the most accurate way of doing it with a chuck like this, but I didn't think about it, so. Well, I'm way off anyway. I guess that's why you should do that. Apparently I'm leaning, or this is not in there straight. I'm gonna put it right there. See if we can get it lined up here a little bit. There we go. It'd be nice if that thing would tap that. I had one of them snap-on tap 1/2 inch 13 the other day that wouldn't even tap a hole. Maybe it was just had something wrong with it, I don't know. This one seems like it's working fine. And this steel seems fairly hard. It may be work hardened or something after all the milling I've done on it, but it took a little bit to get it drilled out. Get this thing down a little bit. I don't know how well this T-nut's going to work. It may still not be in the right spot in that chuck or on that rotary table to work, but I'm going to try it anyway. Using the old anchor lube I got from Stan at Bar Z Industrial, so seems like it's working pretty well. It's still fairly tough, it really is. I don't know what kind of steel it is. It came from a manufacturing facility over in, they build a lot of oil field stuff, so it could be some pretty hard steel, I don't know. Alright, that seems to be working. Seems like it went all the way down. Let's get it out of here now and see if that bolts a thread in it. I would normally try to power tap some of the, up to 1/4 on this little mill. Power tap's pretty good, but this 10 by 1.5 is, I don't believe it would work, and I figured it'd be a tough one to do anyway, so. Okay, well, I guess here's the moment to see if those bolts I have will fit that. Okay, I need to shim for that. That's pretty, right on the edge of that, it's on the top. Let's see how it works. Yep, it's threading in there fine. So, I guess there's one down, and I just need to cut a bunch of them back hard. I need to chamfer these holes a little, but let me turn you around here and show you what we got going on here. So, let me hook you on here so I won't wiggle you. I was just trying to see how I made this. It looks like crap, I know, but I rounded the end of this. I got a little burr on there from this tap job, because I wanted to get this in as close as I could to there, and it may be all right. I get another one built, probably be in there. I think I showed you this earlier. I don't remember now. I've had company a lot today. Here's the stick, but see how, I'm sure you can't see, but let me just turn this up. Now you can see it. See how that won't go all the way up? But I need to kind of round this end here into a radius and try to get that up closer. Even this part is rounded. This slot up in here is rounded into a radius, and I don't know what size radius that is, and I'm just taking the grinder and, you know, grinding it, because I don't really have any other way to cut a radius without figuring out a way to set this up if it's not ready to go yet. So anyway, I just update you. After I get another one made, I guess I'll stick them in here, and I'll take a measurement with 2 bolts and see if I made my minimum of 3 3/4 is what I need. I'm hoping it's going to be have a little extra where I have to pull them out just a little ways. See, if I ended up right there on that mark, I wonder what that would be. It's kind of hard to measure that. Let's see what that ends up to be. Yeah, that's 3.9. So it's going to have to be inside, and it looks like it is inside that mark. I need 3.740 is about what I need, so let's move this into right there. That's what I'm going to end up needing, so that means I'm going to have to be, it looks like I'm going to have to be about a 32nd inside that. It's going to be close. If this don't work, I'll have to probably set that rotary table up and probably figure out a way to see if I can put a true radius in there and find a way to measure that radius probably and get it exact. Anyway, I'm just updating you on that. This may conclude part 1, just in case. I'll kiss you goodbye here. I feel like we're going to have a big long series of stuff about this. I guess it's okay to do that. I don't usually like getting involved in long series, but this is going to be prep for the new mill, and I got a lot of stuff I may share with you that we're going to do some construction in here too to get ready for that mill. So this will be part 1 of prep for the mill, and as Brian would say, thanks for watching and thanks for subscribing. We'll catch you later.